Welcome everyone, and on this live demo we're gonna cover some tips how you can make your mobile app faster using product science tool. So first of all, a few words about myself. So my name is Igor, and I'm engineering manager at Product Science, and I'm I manage the web team, front-end team, and I have mostly full stack background, full stack web background, and also web infra. But in general, I'm mostly passionate about the front end, UX, typography, accessibility, and all that stuff, and of course performance, because performance is a base for any user experience, and you can't build a good app without making it fast. So if you're a mobile engineer, I think you know that making it fast is sometimes is a challenging task, especially if it's some old app with a big code base, and if you work with multiple teams and you have a legacy code base, and some people who wrote this already doesn't work in the company, and you can't ask them why they did that this way. And usually most of the tools that's supposed to help you with performance don't actually provide the root cause. There are some ways to, like with observability tools, to see like that something is slow, but you can't actually find what's exactly is slowing the app down. And sometimes it's really hard to get into the root cause of that problem. And usually you need to make your app faster. You need to instrument it, you need to build it again, and record some profile and analyze it, and you need to build it again because you don't have enough data, and you need to like instrument some other places of your app, and usually it's takes literally days to make it work and to find like some any significant impact inside that will make you some impact. And even if you made the instrumentation, you need to maintain it, and your apps are always changing, and all your work done with instrumentation, the app will be outdated really soon. And instrumentation itself is a very challenging task. You can't instrument everything because you will see a lot of noise from like functions and methods that don't actually affect the performance of the app, or some third-party tools or like system libraries. And Product Science tool helps you with that. So when you install the plugin in your app, it will automatically instrument it, and it will only instrument things that can affect the performance. So it filters out like most of the noise that is not essential for performance optimization, and only show things that are important. And also you don't need to maintain it because it will every time you make a new build with new features, it will automatically instrument that part too. And yeah, this is like our like first unique feature that Product Science have. Another one is that you can record video. And when you record the trace of some flow of your app, you you record not only the trace itself, you also record the video, and Product Science tool automatically sync video with the trace. And it's like very precise. So basically you can navigate on each frame and see exactly what's happening in that exact moment, what functions are called, and what's slowing your app down in this exact moment. Another unique feature is that on the when you record a trace and you see this flame graph, you can click on any slice, so basically on any function call, and you can see how you get there. For example, if you have a flow that involves like click on some link and open the page or open the screen, you can click to the end result of this flow, and it will show you the execution path of this whole process. So basically, this is the chain of functions that were called in specific order to get to the result from some user action, like tap on button or link or whatever, and the end result to show pop-up or show the new page or like something like this. And you can easily understand like what's happening in your page, in your code. Maybe some other process is taking the main thread, or you need to reshuffle your network requests or things like that. And it's very easy to understand, even if the app is complex, and even if you're not, if you don't have like a technical background, if you're product manager or something like this. So let's jump to the demo, and I will show you the demo, the trace of the Antenna Pod app. This is the podcast player, and it's open source. So basically, you can open source code. You can find source code of this app in GitHub and see exactly how it works. But I honestly not familiar with the source code of this app, and I want to show you some insights that I could find even without like any knowledge of how exactly it works inside. And you can imagine that if you know, you obviously know the source code of your app, and you can find much more insights if you're familiar with the code. So the tool will be even more powerful for you. So, okay, so this is our app. So we already recorded the trace for this, for the simple flow. So on the left side, you see the video. You can play it, and you see that we clicked the image, and we showed, and the app showed the information about the podcast. So we can see it, we can use this line to precisely jump into some specific frames to see what exactly is happening. So you see, we clicked the link, we showed this pop-up, some loader, and first we show the text here, and then we show image and another image here. So you see this this whole thing took about a second, slightly more than a second. So on the left you see the video, and you can also make it a little bit slower. You can loop it, so it will be easier to catch things there. And this is unique feature, so no other tools can help you with sync your video and like what's actually happening on the screen with the trace. So we can zoom in, and you can see this line with the frame numbers. So it shows where exactly each frame's and what's actually happening here. And the red ones is the frames that are slow. So something happening here, some functions, some methods called here, and took like too many resources or whatever, and it's getting slow. So we don't want to see, ideally we don't want to see these red things, especially on the places where we see some animation. For example, if you scroll and you see any animation, if you see drop frames, it will be visible for users. So you don't mention drop frames if nothing happens on the screen, but if you see animations, you want to avoid this at all costs. Also, you can see that we have these tags here, these flags. So this shows the the flags that we put into the code so it will appear here in the trace, and you can click. So these two shows the actions. So we clicked on the image, and this one actually shows the result, like what we want to see in the end. So this one shows the image set to cover, and this one says image is set to background. So both of this. So I recommend to put this product analytics tags into the same methods that you use to collect other app analytics. You probably already use some tools to get some product analytics, like Mixpanel or Panda or something like this. And I recommend to put these flags in the same methods that you use to call to send events to these tools, so you can also debug them and to see if they're actually sending events in the right moment. For example, sometimes you can send some event about some user actions, and they actually don't represent what users see. For example, you can say that the page is loaded, and we can show the content is shown, but in fact, for some reason, there are some drop frames, there are some animation or something else, and the actual result visible for user might be slightly off, and it will be like few milliseconds or like even more later. So you can also stress test your analytics that you use to optimize your app and do some product decisions. Maybe they're actually wrong. Anyway, so let's move on to the insights. So when we click looking for insights, how we can optimize this. So when you click to this tag, it will automatically select the slice that was used to set this tag, and this yellow line shows the execution path of this like how we get basically here from some user action to the result. And you can see that some of this have N icon. It means that it's network call, and in general it looks very smooth and optimized. We don't see anything that takes the main thread and delays something, and it looks pretty much optimized already. But usually, even in very well designed thing, and you always can find something to improve, and sometimes it's might be significantly better than before. So let's focus on the network request that we use to show this page. So let's click this one, and we see on the right sidebar there's information about this slice, about what's happening here, and how long it will take, some parameters, and we see that it loads some image. So we can open it in background and see that we have this huge image, and we use this image to show this small, this very small icon image. And obviously we don't need it so big, but we're going to return it to this later. Let's make a full picture first, and then we can do some decisions based on that. Okay, so we loaded this image to show it here. There's another request here. We can open it also in a new tab, and you see that this is some kind of it's RSS XML. So this is looks like the source of the podcast RSS feed, and we see that we have all this text information that we show on this screen, and also it includes this link to this huge image. So basically now we know that in order to load that big image, we need to first download this RSS feed with podcast. Okay, let's move on. We're going to keep it here in background just in case, because we're going to need it later. Now we can see another network call here. This is the call to some iTunes API. Let's open it. It downloaded some file of TXT file. We can drop it here too. So this is some JSON, and we can see that here in this JSON we have this. Let me see what we here. We have this feed. Feed URL. This one. So here's the link to the RSS feed that we saw before this one. And also we see that there are some other information about the podcast, and we also see some links to artworks, so basically on that images, and we can check them and open it and see that we see the same image, but it's much smaller. And we can also see that they have different sizes of these images. So we have this, so we can see that it's like 100 width or height, whatever, size 60 and 30. And you can probably check the iTunes API to see the details of this API and to see is it safe to use these images or not. But this looks like the ones that we can actually use to show on our screen instead of this big one. So okay, let's. Now we see the full picture. So when we click here on that image, first we downloaded the information about the podcast from iTunes API. Then we downloaded the Zoom. Then we downloaded the feed. RSS feed with text information that we showed on this screen, and we took the link to the very big image and this one, and we downloaded, and it showed as a preview for the podcast. So okay, let's find a way how we can optimize this. So obviously we don't need this big image. So let me open Google Chrome DevTools. So it's if you load it, it shows that it takes 7 milliseconds to load, but obviously it's cached somewhere, maybe on your computer or on the CDN or on your hosting provider. And the easy way to avoid the caching is just put some random get parameter in the end, and it will load it from scratch without using any caching. So as you see, this huge image actually takes like 1.5 seconds to load when it's fresh, when it's not cached. It's obviously not what we want to do. So we don't need that big image. And also, as we found before, we already know that we can download image from the very first, we can take image URL from the very first call to the iTunes API, and we don't need to wait for the feed to load, to start loading this image. So basically what the obvious, so now it looks obvious that you can optimize this page by taking the video, the smaller video, smaller image from the very first API call, and you can load both feed with the information and the image to show on the page in the same time. So basically, this part and this part could be loaded in the same time in separate threads, and you don't need to wait for the feed to load to start loading the image. So we can measure like loading the image and also decoding it takes like 400 milliseconds. But let's take let's use only the one with just downloading the image. So it's almost 300 milliseconds. And the downloading the feed is 200 milliseconds. So basically, if we can combine these two, we can probably save maybe 20 or 30, 200 or 300 milliseconds. So if we measure the whole process, so it's like about a second. And if we save 300 milliseconds, it means that we can make this process like 30% faster. It's a lot, so it's a huge improvement. So of course, first you need to, before you do any optimizations, you need to first measure before and do some changes and measure after, because sometimes it doesn't make that big difference for some reasons that you can discover later, or sometimes it can even make it slower. But in general, this looks like easy thing to do, and yeah, after so we can cover it in this demo, but in general this looks like an insight that can make this whole process of loading the page much faster. Okay, so yeah, as you see, without any knowledge of how the app work inside, not even looking at the source code of the app, just looking at the trace, we could find the way to improve the critical flow in the page in this app by 30%. I think it's a good good result. So, and this is just one of the examples how you can optimize your app and find insights or like performance insights in your app. There are much more, so you can check our previous videos or subscribe to updates and to see other demos. And also, if you need more information, if you want to like get more detailed demo, for example, if you want to see how it works with iOS apps, it looks pretty similar, but still, you can drop us an email and we can make a demo for you with more details, with more information, and we can answer a lot of your questions there. So that's my demo, and if you have any questions, please let me know. Yeah, and you can also ask any questions on hello@productscience.ai.